How do researchers determine cause and effect relationships with precision? Welcome to the world of experimental research. Hello everyone, welcome to my video. In this video, I will be explaining about experimental research as part of research design and methodology. I'm WINNY Junianty Imradiyah with student ID number 23220203888203038, one of a student of the English Education program at Institute of Islamic Parepare. This video is created to fulfill the final project for the research methodology course taught by Dr. Magdahalena. So, let's get started! Starting with the definition of experimental research. Experimental research is a scientific research design used to establish a cause and effect relationship between variables. It involves manipulating an independent variable to observe its impact on a dependent variable while controlling other factors. The next is types of experimental research. So the easiest way to differentiate the types of experimental research for the first is pre-experimental research. So in this type, there is only one group. The group takes a pretest first, then gets a treatment, and finally takes a post-test. This is how pre-experimental research works. And then the second, for quasi-experimental. In this type, there are two groups, A and B. Both groups take a pretest. After that, Group A gets a treatment, but Group B does not. Then, both groups take a post-test. So this is how quasi-experimental research works. The third, there is true experimental. In this type, there are also two groups, A and B. But first, the members of both groups are mixed together and randomly assigned to new groups, which is Group A accent and Group B accent. Group A accent and Group B accent are now mix of members from the original groups, which is Group A and Group B. After this, both groups take a pretest. Group A accent gets a treatment, but Group B accent does not. Then, both groups take a post-test. So the main difference in true experimental research is the randomization step, where participants are mixed and randomly put into the experimental and control groups. Okay, next we move to the sampling techniques. Sampling is a critical step in experimental research to ensure the validity and reliability of our findings. In this slide, explain two main types of sampling techniques. The first is probability sampling and non-probability sampling. First, probability sampling. This technique gives every individual in the population an equal chance of being selected. In simple random sampling, every individual is selected randomly without any specific criteria. And then the second is in stratified sampling. So the population is divided into subgroups such as age or gender. And samples are taken from each subgroup. So this ensures all groups are represented in this study. The next, there is a cluster sampling divides the population into clusters such as neighborhoods or schools, and then selects clusters randomly for study. And then next, we have non-probability sampling. This technique is less formal and does not ensure that everyone has an equal chance of being selected. The first, in purposive sampling, we intentionally select individuals based on specific criteria or the purpose of the study. For example, we might only choose participants who have used a certain product. The next is convenience sampling. Here, participants are selected because they are easily accessible. While this is fast and simple, but it may not represent the entire population accurately. So both techniques have their advantages and limitations, and the choice depends on the research goals, available resources, and population characteristics. Next, we move to the techniques of collecting data. In experimental research, collecting accurate and relevant data is essential for drawing meaningful conclusions. So let's look at several techniques commonly used for data collections. Here we have the first, observation. So this involves directly observing participants to gather data about their behavior or maybe performance. For instance, in a classroom study, we might observe how students interact with a new teaching method. And the second is interviews. Interviews can be structured or semi-structured, depending on the level of detail we need. This technique is particularly useful for gaining in-depth insight into participants' experiences, opinions, or perspectives. The third is questionnaires. These are sets of questions given to the participants, which can be open-ended or closed-ended. Open-ended questions allow participants to express their thought freely, while closed-ended questions like multiple choice or yes or no provide specific, measurable answers. The next is tests. Tests are used to measure participants' knowledge or performance before and after an intervention. For example, a pre-test and post-test can show how effective a new teaching strategy is in improving students' understanding. Finally, documentation. This involves analyzing existing records or documents such as attendance logs, medical records, or previous reports to gather relevant information for the study. So by combining these techniques that we have here, researchers can collect comprehensive data that provides a clearer picture of the phenomenon being studied. So we are in techniques of analyzing data. So once we have collected the data, the next step in experimental research is analyzing our study, analyzing it to draw meaningful conclusions. Depending on the type of data we have, we can use quantitative, qualitative, or mixed methods approaches. So let's discuss this each in detail. So the first, we have quantitative analysis. So this technique focuses on numerical data and uses statistical method to test hypotheses or relationships between variables. So common examples that we have here, the first is t-test. This compares the means of two groups to determine if there is a significant difference. For example, we could use a t-test to compare test scores of students who experience different teaching methods. The second, we have ANOVA, or analysis of variance. This technique is used to compare the means of 3 or more groups to identify variations. For instance, comparing the performance of students across 3 different schools. The next, we have regression analysis. This helps us explore relationships between variables such as how study hours impact test scores. It can also predict outcomes based on certain factors. And then the next, we have descriptive statistics. These include measures like mean, median, and standard deviation, which summarize the data's basic features. So quantitative analysis is particularly useful for identifying patterns, testing hypotheses, and making predictions. So we move to the qualitative analysis. Qualitative analysis, so it is applied to non-numerical data, such as responses from interviews, observations, or open-ended survey questions. The first we have here like coding. So this involves labeling or categorizing data into themes or patterns. For example, coding interview transcripts to identify recurring ideas or sentiments. The second, content analysis. So a method used to interpret and quantify the presence of certain words, themes, or concepts within qualitative data. The third is thematic analysis. This focuses on identifying and analyzing common themes across the data, providing insight into participants' experiences and perspectives. So qualitative analysis provides depth and context, allowing us to understand the why and how behind observed phenomena. So we move to the mixed method analysis. So mixed methods combine both quantitative and qualitative approaches to gain a comprehensive understanding of the research problem. For example, we might use quantitative analysis to measure how effective an educational intervention is, and qualitative analysis to explore participants' feelings or experiences with that intervention. So this approach ensures that we get both the broad trends, quantitative, and the deeper insights, which is qualitative. So by carefully selecting and applying the right analysis techniques, we ensure our findings are accurate, reliable, and meaningful. So we can conclude here that experimental research is a systematic approach to investigating cause and effect relationships between by manipulating variables and observing outcomes under controlled conditions. It is highly effective for testing hypotheses, developing interventions, and improving educational practices. So as educators, incorporating experimental research into teaching and learning can help us create innovative and evidence-based solutions to classroom challenges. However, experimental research requires careful planning, adequate resources, and a clear research objectives. So, thank you very much for your attention. I hope this video helped you understand experimental research better. See you in the next video, and thank you again. Bye-bye.